Welcome back to some more geometry. We are talking about parallelograms. Let's see what we can do with those. So let's start with what a parallelogram is before. First off, it's all based off quadrilaterals. So just to be a quadrilateral, you just have to have four sides. As you can see, it doesn't matter the shape, as long as it has four sides, consider quadrilateral. Now, a parallelogram builds upon that. So it's a quadrilateral or a four-sided polygon with both pairs of opposite sides parallel. That's what makes it parallelogram. Has four opposite sides parallels. These two will be parallel to each other. These two will be parallel to each other. That's great news because as when we talked back in chapter 3 about lines being parallel, we can go ahead and assume certain things. We're going to be talking about alternate interior angles, alternate exterior angles, corresponding angles, consecutive angles. All going to help us out here. All that information. So let's move on. So there's the next couple of things are properties that is true about quadrilaterals, things we can go ahead and assume. So this first one says if your quadrilateral is a parallelogram, so if you have a parallelogram, then not only are the opposite sides, so remember this says if it's a four-sided polygon with opposite sides parallel, so a four-sided polygon with opposite sides parallel, parallelogram. So all this can be combined now. Then what's also true about parallelograms is that opposite sides are congruent. Congruent, huh? That means they equal each other. Remember, congruent, equal each other. So to find the value of x and y, we set them equal to each other like we said. So here, we'll start with x. We'll have x plus 20, the top of x, equals 5x. And then for y, we'll say y minus 4 equals 11. That helps us solve that a little bit better. So solve for x, minus x, we get 20 equals 4x divided by 4. What's the value of x, y'all? 5. Good. Here, solve for y, we add 4 to both sides. So what's the value of y? 15. Good job. Good job. All right. So that's this first property. Let's go to this next property. So now this next property, again, so talking about parallelograms. If a quadrilateral is a parallelogram, so we know it's a parallelogram, then opposite angles are also congruent. The angles are also congruent. So opposite angles are equal to each other. Not consecutive or adjacent, opposite. Opposite is very specific. And it's kind of common, like kind of obvious when you look at it. You know for sure this angle doesn't equal that one just by the size of the angle. So hopefully you guys, very intelligent people, figure it out. So what is the value of y equal? That one's really easy. 75. Good. But let's look at x. To do that, we'll do 2x minus 1 equals 105. Solve for x, we'll add 1 to both sides. 2x equals 106 divided by 2. What do we get, y'all? X equals 53. Yes. We are just sailing through this. Hopefully you're pausing and writing this down and trying these out yourself. But this chapter will be somewhat, I'm not going to say it's going to be easy, but it will be easier than most. So that's why I'm not too stressed about you kind of jam-packing this at the very end. And that will also make for an easy chapter test at the end. All right, so move on here, y'all. So like we talked about parallel lines, there's something true about parallel lines. Opposite angles, what is it? Alternate interior angles are congruent, alternate exterior angles are congruent, consecutive corresponding angles are congruent, and consecutive interior angles are supplementary. So we're still talking about that right here. So if a quadrilateral is a parallelogram, then the consecutive interior angles are supplementary. It means this angle and this angle right here make 180. So angle M plus angle J equals 180 here. So we know what angle M is. It's 50. What will be the value of angle J here? Yes, we'll subtract 50 from both sides. We find the value of angle J is equal to 130. 130. So since these are consecutive, what will K be? 50. And of course, this is still true. These are opposite angles. So they'll be equal. So these are opposite angles. This will be equal as well. Right there. Good. Now, in a parallelogram, if a parallelogram has one right angle, then they're all right angles because using the rules of parallelogram, these are supplementary. So that means if this is 90, this has to be 90 because it has to make 180. If this is 90, using the rules of parallelogram, opposite angles are congruent, makes that 90, makes that 90. Now, what kind of parallelogram is this? It's a special kind. It's a rectangle. It's a rectangle. All right. Easy stuff right there. All right, next couple ones. We're almost done here. So if a quadrilateral is a parallelogram, then the diagonals will bisect each other. When you draw the diagonals, as we talked about in 6.1, they will cut each other in halves. Now, the diagonals are not the same. The whole diagonals are not the same length. So BD does not equal AC. But when they intersect, they cut each other in half. So BP equals DP, AP equals CP. So that being said, if AP is 12, what is the value of PC? Also 12. Good. If BD is 20, what's the value of DP? Half of that, 10, because it got bisected. Good. So here, we need to find the value of W and find the value of B. So for W, again, like we said, these are equal to each other, so we set them equal to each other. We'll say 4W minus 7 equals 2W plus 3. And then I'm going to just change the color so we don't get confused. For B, same thing. We set them equal to each other, so 3B plus 1 equals 2B plus 5. We'll start with the W, so make sure you pause and try this out yourself and see if you get the same answer. So I will subtract 2W minus 2W and then add 7. Add 7. That way I get that out of the way and that out of the way, leaving me 2W equals 10. So W equals 5. Good. And let's look at B. So I will do minus 2B minus 2B minus 1 minus 1. That's gone. That's gone. Leaving me B, 1B equals 4. And that's that. All right, last property about parallelograms. If your quadrilateral is a parallelogram, then each diagonal separates the parallelogram into congruent triangles. Isn't that crazy? So we'll look at this first. When you draw this diagonal right here, this triangle that's formed over here is the same as this one right here. They're just kind of backwards to each other, but they are congruent to each other. Same thing right here. If we do the short side, this is congruent to this right here. Now, if you do both, ooh, man, you do both. This triangle right here is congruent to this one over here. And this one down here is congruent to this one up here. So we'll do 1 to 1, 2 to 2, 1 to 1, 1 to 1. These are equal to each other, and those are equal to each other. All right. Hopefully this helped y'all. If you need help, let me know. Bye.